Okay, so in this lesson on linear inequalities, we're going to eventually at some point solve linear inequalities. Now this is part one, so before we can get to the complex part of solving more complex linear inequalities, let's talk about the notation and what the graphs looks like. But before we do that, let's recall this very simple equation, linear equation. So let's suppose you were asked to solve x minus 1 is equal to, let's say, 2. X minus 1 equal 2. Now, that's a very easy one. You can look at this and determine what the answer is, what the solution is. But remember what we did was we used the addition property of equality, so we added 1 to both sides, and then we combine like terms, so I get x is 3. So the solution to this linear equation is x equal 3. So that's the only real number that makes this equation a true statement, because 3 minus 1 is 2. Now what we're going to eventually be looking at here is a linear inequality. Now remember, inequalities have these symbols. So less than, remember this is less than, greater than. So this is less than symbol, this is a greater than symbol. This is the less than or equal to. And this would be the greater than or equal to. Right, so linear inequalities, or inequality statements for that matter, will have these symbols. If it's an equation, it just has an equal sign. So linear inequality, an inequality will have these symbols. Now let's suppose we wanted to look at this. Suppose we wanted to look at this inequality. Same expressions, except this time we're going to say greater than 2. Or greater than 2. So again, we're trying to solve this linear inequality. We're trying to find out what numbers can I plug into x, so that way this side will be bigger than 2. The left side will be bigger than 2. So still using the addition property of equality, just like we did here, and then combine like terms, you get x is greater than 3. Now what we found here was that any number bigger than 3 is a solution to this inequality statement. So for example, 4. Check x equal 4. So when I plug 4 back into the original inequality, I get 4 minus 1, and the question is that bigger than 2? Which is the right side. So 3 is bigger than 2. So 4 is a solution. So if you try, let's say 7.2, same thing. You go back to the original. So 7.2 minus 1, and the question is that bigger than 2? Well, 7.2 minus 1 is 6.2, and 6.2 is bigger than 2. So in fact, what we're finding is that any number bigger than 3, any real number bigger than 3 is a solution. So in the previous, where we had this equation, you could actually list the solution. There's only one solution, you were able to list it. You would just say x equal 3. Here though, if you notice, there's an infinite number of solutions. An infinite number of solutions. So notice the word infinite. Infinite number of solutions. So you can't list them. There are too many to list. There's an infinite number, so you would never be able to list them. So what we do instead is we talk about the graph. So here's where we're going to start graphing the solutions. So if this is 0 on the number line, and this is, let's say, 1, 2, 3, now notice this says that all the solutions have to be strictly bigger than 3. So 3 is not a solution, because notice if you check x equal 3, and where we see the variable x, you plug in 3, I get 3 minus 1, and the question is that bigger than 2? So is 2 bigger than 2? The answer is no. 2 equals 2. 2 is not bigger than 2. So what we're going to do instead is on the number 3 right here, you always have to use this right here. When you get x by itself, you have to put this number in the number line, and we're going to use an open circle. So open circle implies it's not a solution, it's not part of the graph. So open circle is not part of the graph, not part of the solution set. Okay? So, and then we're going to shade in every number to the right of it, because I want to shade in every solution bigger than 3, so every number bigger than 3 is a solution. So you're going to do something like this, draw an arrow to indicate that it keeps going to the right. So that's what your graph looks like. All right, now, you're also going to be told at times that you want to write this in interval notation. So let's talk about interval notation. All right, interval notation. All right, once you graph the solution, once you graph it, then you just read a graph from left to right. Always read a graph from left to right. So notice that when I start discussing the idea of my solutions, I indicated the solutions were greater than or equal to 3. So any number bigger than 3. Now, notice that this is an open circle. Since this is an open circle, we're going to use parentheses. So we're going to use parentheses with an open circle. So notice you use parentheses with an open circle. Now, in a little while, we're going to talk about bracketing closed circles. So closed circles, brackets in a little while. But if it's an open circle, you use parentheses. You start at 3, so you're going to say 3, comma, and then all the solutions are any number bigger than 3. So 100, 200 million, 5 billion, and so on. So that's going towards infinity. And always with infinity, negative infinity, you're always going to use parentheses. With infinity or negative infinity, you're going to use parentheses. All right, so that's your interval notation. So you're saying my solutions are any number from 3 to infinity, not including 3 because of the parentheses. We had an open circle. There was no equal sign, so you use an open circle and parentheses. Now the other thing that you're going to have to write this as in terms of My Math Lab is this, and you're going to see this in one of the worksheets also. You're going to put this in set notation. So we talked about interval notation. Now let's talk about set notation. Set notation. So set notation looks like this. So you write as a set. So you're going to say the set of, and my variable here is x. So you're going to say the set of x's such that. So this symbol right here means such that. Such that. So the set of x's such that, and then you just write your inequality such that x is greater than 3. And you're done. And just close the brace. So set of x's such that, and then your inequality when you solve for x, such that x is greater than 3, and you close it. All right, so when we talk about, in the next few lessons, with linear inequalities, when we talk about graphing and notation, we're going to, remember you have to graph this, so notice open circle versus closed circle. We're going to talk about closed circle. Interval notation, and then set notation. Okay, now let's look at this. So right now what we're going to do in this lesson is just kind of talk about notations. All right, so let's look at this. Suppose now what we're going to do is you're going to graph each of these, and then you're going to put this in interval notation. And then set notation. So all we're doing is just discussing the basic foundation before we can actually go into solving more difficult linear inequalities. Okay, so number 1. Suppose you had that x is less than or equal to 3. X is less than or equal to 3. So you solve this inequality and you get all your solutions are x is less than or equal to 3. So you want to graph the solution set for this inequality statement. So my solution set is any number less than or equal to 3. Okay, so notice that 3 is a solution because of the equal sign, because 3 is less than or equal to 3. 3 equals 3. So since you see an equal sign, you can use a closed circle. So you can put a closed circle on 3, just like this. And I want to graph all the numbers, all the real numbers, all the solutions are going to be less than 3. So you're going to go this way, to the left, with an arrow. Don't forget to draw an arrow. So there's your graph. This is what the graph looks like. Okay, so there's your inequality notation. This is your graph. Okay, now let's talk about interval notation. All right, so you regraph from left to right. So notice that this arrow is pointing towards your negative numbers. So you're basically saying negative 100, negative 1 billion, negative 3 trillion, and so on. So that's going towards negative infinity, but you always go from left to right. So this arrow is pointing towards negative infinity. So and remember, with infinity, negative infinity, you always going to use parentheses. So you can say parentheses, negative infinity, comma, all the way to the number 3. And then since 3 is a solution, remember the equal sign, closed circle, equal sign, you can use a bracket. Use a bracket. All right, so there's your interval notation. So all my solutions are from negative infinity to 3. Always read from left to right. Negative infinity to 3, including 3 because of the bracket, closed circle, equal sign. The set notation looks like this. The set of x's such that, and you just write your inequality symbol, such that x is less than or equal to 3. So there's your graph. Okay, number 2, suppose you had that that y is, let's say, greater than negative 1/4. Y is greater than negative 1/4. Okay, so you go to the graph and you locate negative 1/4. So negative 1/4 is between 0 and negative 1, but closer to 0. So let's say it's right here, negative 1/4. All right, so that's negative 1/4. Now, since there's no equal sign, so you just strictly graphing the solutions that are greater than negative 1/4. So any number bigger than negative 1/4, but not including negative 1/4 because there's no equal sign. So in that case, we're going to use an open circle. So you put an open circle, just like that, and then you graph all the solutions that are greater than that. So you go to the right, just like this. All right? So once you graph it, you can easily talk about the interval notation. So interval notation. And so you read a graph from left to right. So I'm going to start at negative 1/4. Since it's an open circle, since I can't include negative 1/4 as a solution, you're going to say parentheses. So parentheses, negative 1/4, comma, all the way to infinity. And then set notation, you're going to say set of, and always make sure you use the correct variable. So you're going to say the y's this time. The set of y's such that, and then you write your inequality statement. Says that y is greater than negative 1/4, close brace. All right, number 3. All right, now, suppose you had x is, let's say, less than 4. X is less than 4. All right, so again, I'm trying to graph the solutions that are less than 4. So you're going to, since there's no equal sign, you're going to put an open circle on 4, and you're graphing all the numbers that are less than that. So you can go to the left, just like this. All right, and then your interval notation. So remember, always go from left to right, so the arrow is pointing to the left, so you can say negative infinity, open parentheses, negative infinity, comma, all the way to 4 with parentheses. And then your set notation, you're going to say set of x's such that, and you write your inequality statement, such that x is less than 4. All right, now look at this one. This will be number 4. Okay, number 4, suppose you had this. Now sometimes, see how the variables here are listed on the left-hand side? With an inequality, that's always a good thing, is to have it on the left-hand side. Because if you don't, for example, let's say you're told that 2 is less than x. All right, 2 is less than x. What some students do is they'll put the open circle in 2, which is correct, because you can't include 2, cannot include 2 because there's no equal sign. But then they make a mistake and they see the less than, and less than they automatically think to the left, less than. And so they shade this part in, but that's not correct. You don't shade that part in, because what that says right here is that, remember, x is your solution, so that means that 2 is less than any other solution, any other number that's a solution. So that means that 2 is the smallest. 2 is the smallest solution. That's what that means. Okay, now I got to be a little careful. You can't include 2, but any number less than any number bigger than 2 would be a solution. So I got to be careful how I say this. 2 is, we can't include 2 as a solution, so I'm going to put this in quotes here. So 2 is the smallest number you can put in your interval notation on your graph. So what that means is that if you go backwards like this, if you go backwards, that means that x is greater than 2. That's what that means. So if 2 is the smallest, then that means you got to shade in every number to the right. And so you got to be careful. You have to be careful when you have the variable on the right-hand side. And when we solve these inequalities, you're going to see at times that the variable we're going to end up having the variable on the right-hand side. And you don't have to. You can bring the variables to the left-hand side all the time, just like you did with an equation. It does not have to always be on the right or on the left. But you got to be careful with these. So, for example, if you had, let's say, 5, where you had negative 2 is, let's say, greater than or equal to x, negative 2 is greater than or equal to x, what that means is that negative 2 is the largest. Negative 2, see, is greater than any other number. So negative 2 is the largest solution. So that means that if you put negative 2 on the number line, and it's closed because of the equal sign, so negative 2 is a solution. That means that negative 2 is the largest one. So you can't shade in to the right because negative 2 is the largest solution. So you got to shade in to the left. So if you write it backwards, when you go backwards, you're saying x is less than or equal to negative 2. That's what you're saying. So that's what this is right here. X is less than or equal to negative 2. All right. So in interval notation, let's talk about interval notation. Here you're going to say negative infinity to negative 2 with a bracket. Remember, negative infinity is always parentheses. And you use bracket here because of the closed circle. And set notation, you say set of x's such that, and it doesn't matter which one you use, I'm going to use this one here, such that x is less than or equal to negative 2. Over here, you're going to say parentheses because of the open circle, 2 comma all the way to infinity. Remember, infinity, negative infinity, always use parentheses. So there's your interval notation. Set notation, you're going to say set of x's, such that, and again, it does not matter which one you use, says that 2 is less than x or x is greater than 2, does not matter. Okay? All right, so that's going to take care of this basic notation. And in the next lesson, we're going to start solving inequalities just like we did with this one, except it's going to be a little more complicated.